Spanning tree protocol needs a way to communicate amongst the different switches, and it does that through frames called Bridge Protocol Data Units, or BPDUs. And so let's take an in-depth look into what are Bridge Protocol Data Units and what do they look like. We already know what the process is, and that is to elect root bridge, calculate root path costs, elect root ports, elect designated ports, elect alternate ports. We know the process now that spanning tree protocol uses, that spanning tree algorithm, to determine how it's going to send traffic in the future. But what it needs to do to elect these different root bridges and root ports and all of that, what it needs is information. And the information that gets passed from switch to switch down each one of these links. And each link has its own Bridge Protocol data unit that it sends back and forth. So we have quite a bit of Bridge Protocol data units that are being sent back and forth. So let's take a look at what that looks like. The information packed into a Bridge Protocol data unit is about 35 bytes of information. So here I have listed out what pieces of information it looks for. So first of all, you can see there's a protocol ID, there's a version ID, there's a type information, there's some flags that happen. All happens within the first 5 bytes of this. So the first 5 bytes are just some information. We're not going to get too crazy into that. The last part of this, we haven't talked about message age, max age, hello time, delay. We haven't talked about those yet, but those are different settings there are for STP. Things that, like the hello time, is set to how often these BPDUs are going to be sent across the link, and the default is 2 seconds. That's not what this 2 represents. This 2 represents that there's 2 bytes here. This bottom section here is the bytes for each one of these. So we're not going to pay attention to that right now. The big focus that we have in this video is going to be the root ID, the root path cost, the bridge ID, and the port ID. All of the information that we've been using to go through that process, that spanning tree algorithm process, to determine what is going to be the ports that we shut off. Essentially, that boils down to what ports are we going to shut off, so that way we don't get these routing loops, or excuse me, not routing loops, switching loops. We're going to take this from this perspective of switch 2 right here. And the switch 2, what it's going to be sending out each of the links, the Bridge Protocol data units that it'll be sending out each link. Now, initially when this starts, the switch 2 isn't aware of what the actual root bridge is going to be. So what it does initially is it populates the root ID with its own bridge ID. So the root ID would be the bridge ID of switch 2 until it learns of a better option that's out there. And it will learn of a better option with time as BPDUs get communicated back to it. And once that happens, and this switch realizes that there is a better root bridge that's out there, that is a root bridge that has a lower priority or a lower MAC address to it, then it will adjust. It will now know that there is a different root bridge out there, and then it will change the root ID to be with whatever it discovers is new. Now, don't forget that the bridge ID is that priority plus the extended system ID, which we know of VLANs. The priority is something that we set, so that way we can skew the results or change the results of this, of which switch is going to be the root bridge. And then we have the MAC address, and that's for when things are set to default, then it can use the MAC address, and we know the MAC address is going to be unique. Once it learns of what the what the actual root bridge is, then the bridge protocol data units that it sends out is going to represent that. So inside this root ID, what we could actually do is put in that priority 4096, and then it's going to have that VLAN information in it. So we would have that VLAN information in it, and then we would have the MAC address. In this case, it's CC. I'm not going to add it all in there, but you get the point there. So that is going to be what the root ID that it sends out, that it's going to be as it sends it out, each of those links. All right, I took the liberty of go ahead and filling in the ones and zeros that represent switch 1. So the bridge protocol data units now that switch 2 sends out will have the root ID of the root bridge, which is going to be switch 1. So you can see 4096 is 0001. The extended system ID just represents the VLAN that it's a part of, and I just put the default VLAN in there. And then the MAC address, CC, is represented in these other ones and zeros that come across there. So that's going to be what's going to be sent out at this point as in the bridge protocol data units. All right, so next what this switch 2 needs to do is determine the cost of each of these paths. And so what it will do is it'll take whatever the BPDUs coming into switch 2, and then it will add the cost of the interface. So the BPDU coming from switch 1 is going to have a 0 path cost at that point in time. And as it comes into switch 2, it will then say that's coming into a fast Ethernet, which is 100 megabits per second. It's coming into 100 megabits per second. So I'm going to add a cost for this link is going to be 200,000. And so now the cost to get from switch 2 to the root bridge is going to be 200,000. So let me write that into here. And now that is going to be what's going to be sent out in its bridge protocol data units from then on out until it learns of a lower cost. So $200,000 is going to, or excuse me, 200,000 is going to be set in that root path cost. All right. So that is the root path cost. The bridge ID is pretty straightforward and doesn't change no matter what. And that is from switch 2, the bridge ID that is going to send out is all going to be what is associated with switch 2. So that way these devices know that they're connected directly to switch 2. So what's going to be put into here is, once again, the priority, so 32,768, plus that extended system ID, plus the MAC address, so that's going to be all included in there. I once again translated this, so now you can see it's into ones and zeros at that point. The last thing that's going to be sent out is going to be changed depending on the interface it's getting sent out from. So in this case right here, if it's on this link right here, it's going to be sent out with whatever priority is set on that interface. And let's say it's just the default, which the default is 128. So let's say it's 128. And so it's going to be the priority plus the port number. And so somehow this gets translated into a port number. We're just going to say 47. What's being sent out on this next one is 48. So instead of 47, it will be 48. And what's being sent out, this 45 right here, is going to be whatever priority is plus 45. And then what's ever sent out, this last link is going to be 46. So that's what gets sent out. And that way, when this other switch gets that information, then it can make a determination on what's going to be its root port. So this information gets all sent out, and now other switches can make decisions on what's going to be the root port and what's going to be the designated port. There you have it. Those are the bridge protocol data units that are going to be sent out along each one of those interfaces. Some of those are going to remain the same no matter what, such as the bridge ID. Some of those are going to change, like the root ID and the root path cost, while others, like the port ID, will change for every single port that it's sending out on.